All right, so picking up with the next problem, we've got root k over root k minus root g. Now, what you're supposed to do is if you ever have square roots in the denominator, you're supposed to rationalize them. And with the previous problem, there was only one square root, or one, it was a fifth root. There was only one root there. Here, it's a little more complicated because you've got a couple of roots that are subtracted. If you ever have roots that are added or subtracted together, what you're supposed to do is use this thing called the conjugate. All the conjugate is just this. If I've got a pair of things and there's a minus in between, I'm just going to multiply by the same thing with just a plus in between. If it's the reverse, it's also true. If I start with a plus sign on the bottom, then what I multiply on top and on bottom here is going to have a minus sign in between. Whatever it is, you just change the sign in the middle. That's all this conjugate thing is. So what we then have, we're going to have this root k distributed by root k plus root g. And then we're going to have to do FOIL. We're going to do root k minus root g and do root k plus root g. So if we do the top, root k times root k, well, the two roots are going to cancel out because you've got two of them. That's just going to give you a plain old k. If you have a root k times a root g, if you multiply two roots together, you just combine them into one root with the two things multiplied under the root. So that's just going to be root of kg. Down on the bottom, we're doing FOIL. So the first terms, root k times root k is just going to give you a plain old k. If you got a root k times a root g, that's going to be root kg. If you've got a minus root g and a root k, that's going to be a negative times a positive. That's a negative. And then again, since you've got a k and a g, we're going to just put kg under this one root sign. Finally, you've got a negative root g times a positive root g. So a negative times a positive is a negative answer. A root g and a root g is just a plain old g. So now the top's pretty much finished. There's nothing else we can do with that. The middle terms, you may notice, are the same. It's just one's positive and one's negative. That means they're going to end up canceling out. If you do that, all that's left is this k minus g. So you've got the k plus root kg over k minus g. That would be your answer. For the next problem, it's a very similar sort of goal here. You've got 2 root 3 plus root 6 over 4 root 3 minus 6. Again, to get rid of roots where you're adding or subtracting stuff, you're supposed to use the conjugate. So if this is 4 root 3 minus root 6, we're going to leave it the same, but just change the sign. Make it 4 root 3 plus root 6. Whatever's down here has to be exactly the same as what's on top. And you do that on top and on bottom. So now what we're going to do is we're going to FOIL these things. The first thing I'm going to do is 2 root 3 times 4 root 3. The straight up numbers, 2 times 4, give me an 8. So the 8 is right there. A root 3 times another root 3 is just a plain old 3. And all this junk gets multiplied together for each individual set of terms. So the 2 and 4 gave me an 8. The root 3 and root 3 gave me a 3. This part is 8 times 3. Next, I'm going to do the outer terms, 2 root 3 times a root 6. 2 doesn't have anybody to go with. That's just a 2. Combine the roots into one root where you multiply them together, 3 times 6. We'll leave that there for now. Inside terms for FOIL, you've got root 6 times 4 root 3. So the 4 just comes on down. Combine the roots. There's a root 6 and a root 3. So that's a root with a 3 times 6 under it. Then your two terms that are last, there's a root 6 times a root 6. That's just a plain old 6. And it's positive, so you put plus 6. Underneath, you're going to do much the same thing. You've got 4 root 3 times 4 root 3. 4 times 4 is a 16. The root 3 times the root 3 is just going to give you a straight up 3. And those two pieces, those two components are going to get multiplied as 16 times 3. In the meantime, you're going to have 4 root 3 times a root 6. We were talking about this earlier. This is a 4. Since it's a 3 and a 6, you're going to have a root 18 because that's root 3 times 6. Down here, you have a negative root 6 times a 4 root 3. So a negative times a positive is going to give you a negative 4. And you've got a 6 times a 3, which is another root 18. Lastly, a negative root 6 times a positive root 6. Negative times positive is negative. And then the root 6 times root 6 is just a straight up 6. Now we can clean some of this mess up here. So 8 times 3 is the number 24. I've got 2 plus 4, and the roots are the same. That's going to be a root 18. So 2 plus 4 is going to be 6 root 18. And then there's this plus 6. It's just sort of sitting there for right now. I haven't done anything with that yet. Down on the bottom, I have a 16 times 3, which is 48. You may notice this is plus 4 root 18 minus 4 root 18. Those are going to cancel out because they're exactly the same. It's just one's positive and one's negative. And then last but not least, there's a minus 6 here. We're just going to bring that on down. So then for the next step, there's two things we got going on here. So I've got the 24 plus 6, which is 30. Underneath, I've got 48 minus 6, which is 42. So I'm just combining the straight up numbers here. Then when it comes to root 18, we're trying to break that apart, because if you have square roots, you may have seen how you're supposed to break them up using a number that has a square root. 9 is a number that has a square root. You can do 18 and break it apart into a root 9 and a root 2, because the 9 times 2 gives you the 18. And root 9 I can do something with, because root 9 is going to turn into a 3. So really, this is going to be 6 times a 3 with this root 2 just sitting there. We've seen previously that a 6 times a 3 is an 18. So this thing is going to turn into an 18 with a root 2 just sort of chilling out, sitting out there next to it. We're still not quite done. This is a never-ending problem here. Something you may notice, 30 and 18 are both divisible by 6. So I am going to factor out a 6. I got a 6 out here. I'm going to factor that out in parentheses, put what I get left, which will be divide this by 6, you get 5. Divide that by 6, you get 3. And then there's a root 2 just kind of chilling out there. That's all the junk in the parentheses. The point of doing that is that now you've got 6 over 42. And guess what? You can divide both of those by 6. That'll cancel this 6 out, so nothing's left except the stuff that was in the parentheses. If you take 42 and divide by 6, you get the number 7. So when all is said and done, you've got 5 plus 3 root 2 over a 7. These problems are long. I get that. All right, we got one left. This one's a little bit shorter compared to the last one. So what do we got? This is just going to be straight up FOIL with square roots. You've got root 7x times root 7x. Well, root 7, or root times a root is going to cancel out. That's just going to leave you with what was inside, 7x. You do root 7x times negative 4 root 6x. Negative 4 is just going to chill out in front. Multiply the stuff together that's underneath. 7 times 6 gives you a 42. Here's an x. Here's another x. That gives you x squared. An x and an x is an x squared. So that's the outside term. Now we're going to do the inside term of FOIL. You got this negative 3 root 6x times root 7x. Negative 3 again is just going to go out and park in the front here. There's your negative 3. We saw this from before. Root 6x times root 7x is root 42x squared. For your last terms, you've got a negative 3 root 6x times a negative 4 root 6x. Negative 3 times negative 4 is a positive 12. Root 6x times root 6x, again, if you multiply the root by itself, it cancels out the root and leaves you with just a straight up 6x. So the numbers in front gave us a positive 12, and then the junk inside gave us a 6x. And those two things will get multiplied together. So going on to the next step here, 7x just comes on down. There's not much going on with it right now. You've got a -4 with some ugly root. You've got a -3 with some ugly root. -4 minus 3 is -7. Those are like terms. And then you've got this big stinking root here, root 42x squared, just kind of sitting there. The other thing I can do, I've got 12 times 6x. 12 times 6 is 72. X comes along for the ride, 72x. Now, since you've got a root with an x squared in it, you can't do much with 42. But since you've got a root of an x squared, that is just a straight up x. So you square root that, it gives you a plain old x. And the x is now outside the square root. The 42 is still underneath because we couldn't do anything with it. And that's a number you can't break down. It is what it is. So the last thing, you've got like terms with x's. Here's a 7x. Here's a 72x. You can add those together and get 79x. And then you're minusing 7x root 42. And there you have it. That is the answer for this one. 79x minus 7x root 42.